Hello, students. Taking a look at one of our last sections, 7.3. And the homework from this section is 1 through 22 and 24 to 25. So pretty close to all of them here. But I did skip number 23 on purpose. So as I looked through, I was like, you know what? Once you start seeing the patterns, many of these are going to be extremely quick, and they're intended to be. That's the goal of these. So let's see here. You've got once we've got a question about a terminating decimal. Remember what we learned in section 7.1 about terminating decimals and what is required to be a terminating decimal and how the factors must be very specific. And let's see here. Do these represent different numbers? This was talked about in class. If you need to, you could write the digits out for a little while and see which of them is probably the best way to write it. Next one says write out the first 10 decimal places of these, which is, again, nothing huge, just writing out decimal places so you understand what the bar represents and how you can record the values. Which one of these is greater? Again, refer back to number 3, write out some decimal places. You might find that eventually they don't have exactly the same values. Let's see here, write the following using a bar to indicate the repetend and give the period of each repetend. Okay, so they're assuming that it continues exactly as it has in the past. So they're looking at repetends that would be visible with what they've shown you. So that's not too bad. Find the decimal representation for each of the following. I've already done a couple of those in the Q&A portion. And we've done some in class. But again, some of these are meant to be quick. Let me give an example here. So let's say, and again, there's multiple ways to do it. You can do it with long division. You can do it without long division. It's totally up to you. So you have options on kind of how you're doing it. Let's see here. So 2/3. There's not much to say about 2/3. You could do division. It would be very quick. You could also scale this one up to have a 9, and then it models after the 7/9 piece. So 6/9, you get something really quick and easy. I'm not going to hit that one because I think I have before. 1 out of 24, or even 1 out of 12, to be honest, because 1 out of 12 would be very similar to this. So 1/12, if you look at this, you get 1/2 squared times 1/3. And I don't know why all of a sudden my writing's looking sideways, so I better fix that real quick. So then I will use the technique from 7.1 to create this first portion here as a terminating decimal. So this would be 5 squared on top and 10 squared on the bottom. And then I have my 1/3, and all I do is bring the 5 squared over. So this becomes 1/10 squared and 25/3. Now, the goal of this is the 1/10 squared, all you're doing is moving the decimal place. You're shrinking it by 2 powers of 10. So if you can take the 25/3, 3 goes in there, what, 8 whole times? 8 goes 24, so 8 1/3. Which is really the same as 8.3 repeating. And then again, take your 1/10 squared. And so now as you do this, 1/10 squared moves the decimal 2 places. So I move it 2 places and I get 0.083, and the 3 is repeating. So that's, again, me kind of showing all the steps along the way to get there. But if you had to do like 5/12, let's just say that that was the number that we were looking for, then as you're doing it, bring over the fact that this is a 5/3 and this is a 1/4, and then factor it up with 25 on top and bottom, and then bring the 25 over with the 5. So I know I have a 1/100, and then the 25 times 5 is 125/3. Well, 3 goes into 12, which is 12 groups at 10, 4 times, so 41. So this is 41, and then what remains is 2/3, and 2/3 would be the 0.6 repeating. So I really have 1/100 times that, which is just 0.416 repeating. Okay. Let's see here. I have a short video on how to do these other ones if the division did take a little while longer. How you can use the repeating remainders to make things a little bit easier for yourself. But you come down here, once they give these to you, hey, try to make your life easier. If you see a 0.5 repeating, you know that's 5/9. If you see a 0.53 repeating, that is 53/99. Okay, nice patterns, nice connections. They make it kind of easy. If you see something that looks like 2.35 repeating, I'll link it back to what I did at the beginning. You could say to yourself, ooh, this looks very interesting. It's very close. If only I had 23.5 with a bar, right? So you could say, well, it's 10 times that. At the end, I just need to make sure I move one decimal place. So this becomes 23 and 5/9. And so then I can multiply by 9 and regroup, and I'd have that number. So this would be 23 times 9. There's a 7 and a 2, 18, 19, 20. So 207. And don't forget to add the 5 on there, gives you 212. So you get 212 over 9. But again, I multiplied by 10 at the beginning, so I have to multiply by 1/10 at the end. And you get 212 over 90. That would be it. Let's see here. Convert the following. It just says to A over B form, so that would be just fine. And that's how you can do those. Express this as a repeating part of an hour. So yeah, you do need to find how many hours, what's the relationship between hours and seconds. Ordering things, if you need to, write out, go back to what you did at the top, write out a few more decimal places as you go. Doesn't have to be that you're trying to do it all in your head. List the next 3 terms in the following arithmetic sequence. This one might be challenging for you. If you do find that this is a struggle, maybe take a moment and turn it back into fractions, because then maybe you can see what kind of pattern we have. Okay. We got the sum of a finite geometric sequence whose first term is 0.1, first term is 3, and it has 4 terms. Here they're giving you, I'm telling you there's exactly 4 terms. So you're going to multiply by 0.3, you're going to do it 4 total times, 3 total times because you have 4 terms, and then you're just going to add them up. That's it. So write it out, add them up. 12, I did a video on if you want to check that one out. How do you think that these are going to fit together? And 13, I even showed in that video kind of how to do something like 13 where things don't seem to match up that nicely. Let's see here. Explain whether the repeating decimal could ever be written as a terminating decimal. Okay. just think about the definition. What is a repeating decimal by definition? What is a terminating decimal by definition? Right, find 3 decimal places between each of the following pairs of numbers. So now we're finding decimal numbers. We used to find fractions using the Kool-Aid property. You can use that again if you convert these into fractions, but you don't need to, as long as you can find a terminating or repeating decimal. So let's say that I was looking between 2.7 bar and 2.7. Now remember, the one with the bar keeps going, 7, 7, 7, 7, 7. So you could find, it just has to be bigger than this one, which would be like 2.70. This one would be 2.77, continues forever. And so just pick a number between them. So 2.71, that is between them. It is bigger than the smaller number, and it is smaller than the bigger number. 2.71. If you want something that's repeating, how about 2.712 and put a bar over the 1, 2? Again, all it has to be is in between those numbers. So infinitely many opportunities there. Let's see here. Find the decimal halfway between 0.9 bar and 1.1. And just remember, what is 0.9 bar, 0.9 repeating from what we did in class or from just your own conversion? So what does that equal? Then you've got find 3 rational numbers between the following. All right, well, what do they want you to do? You can choose. You could put the decimal one into a fraction and use the Kool-Aid property. You could use turn the fraction number into a decimal and then use decimal numbers. So you have a lot of opportunities here. Give an argument why 2 over 26 must be a repeating decimal. What can you say about the length of the repetend without performing the definition, without performing the division? Well, remember, repeating or non-repeating, you have to have simplest form for your fraction. You cannot do this if your fraction is not in simplest form. All right. What else do we have? Write these in fraction form. Again, it looks very similar to what you did back over in some of these other places. Convert the following repeating decimals to fraction form. So it looks very similar. They are trying to make a connection here. 0.2 with a bar, 0.02 with a bar, 0.002 with a bar. I mean, and then 0.0002 with a bar. They're trying to get you to say, hey, wait a minute. How could I do this? Okay. If they're asking you to try something mentally, like 4 over 90, I mean, you're absolutely welcome to do it. I would not recommend simplifying right off the bat. Think about the fact that if you had 4 over 90, you really have 4 over 9 multiplied by 1/10. So if you know the decimal for 4/9, 1/10 is just, hey, bring that decimal place over. And so that's going to be the big idea there. Oh, let's see here. Which one did I say you didn't have to do? 23. Okay. Use some basic facts, very similar to what we had before, actually. If you kind of have already picked up on it, this 21 might be pretty quick. It's meant to be pretty quick. Same thing here, very close, links to those two. I said skip 23. Find the fraction that represents the following. Again, we've got a couple questions. This looks very similar to what we did over here in part B. Now it's over here in part A. But now they're going to tie that together with the idea of adding some more leading zeros. So what should that look like? Okay. Let's see here. Yeah, I think 25. Once you've seen, you will have done this idea, taking a repeating decimal and turning it into a fraction. You would have done that 4 or 5 times already. So they're asking you to do it with variables. And I think that's it. I think I end at 25. Where did I end? 25. Okay. So that does it for here. Hopefully that gets you on the right track. If you have other questions, let me know. All right, off you go.